Sometimes if you want to build something, you've got to make a little bit of a mess. Today we're going to make a mess making some concrete. So concrete has four main ingredients you pretty much have to have or it's in concrete: water, cement, coarse aggregate, and fine aggregate. But lots of times you have extra ingredients to make the concrete do something special. So the cement is a fine gray powder. It reacts with the water, or in a chemical reaction, to make something completely different. The fine aggregate is probably what you'd call sand. This sand's a little bit damp, like you'd make a sandcastle out of. And the coarse aggregate is sometimes river rock that's been rounded by rivers and dredged out, but this is crushed limestone. It's common around this part of the country. A cement mixer rotates the concrete to mix it, just like these ingredients are getting mixed together. The bucket doesn't have baffles like a cement mixer does, so it doesn't mix it as well. So for our experiment, we're going to try to make concrete with lots of little air bubbles in it to make it lighter weight. But with any experiment, you have to have a control. You have to have a sample that you didn't do the change to, so you can compare the two. But you want everything to be as similar as possible, other than the one thing you change. Our hypothesis is going to be that the concrete that has the extra air bubbles because of the dishwashing soap will be lighter weight, but it will still be just as strong. Sometimes your hypothesis is wrong, but you have to have one to have the basis to see whether the experiment worked or not. So we'll make two different test cylinders, one with air and one without air. This bucket's going to have our secret ingredient, the dishwashing soap. We'll put the same amount of everything in, except for the soap. The first ingredient is going to be a 20-ounce cup of water. Usually you don't put the water in first, but we want to get our soap mixed in with the water well before we add anything else. We'll put in about 1 ounce of dishwashing soap. Before we mix any more, we'll add part of our ingredients. Next comes the Portland cement. Because this reacts with water, it could react with the water inside your body, so we try not to touch it. And we're definitely making a mess now. One 20-ounce cup of cement into our control, and one 20-ounce cup of cement into our special soap-containing mixture. Now we'll put in some fine aggregate. 1 cup of sand for each of the buckets. Before we add anything else, we'll get these mixed together. Between each mixing, we'll rinse off the paddle so we don't contaminate our special sample. If you want to do this at home, get a cake mixer. I'm sure no one will mind. Now we're going to add some mixed together Quikrete. It's got fine aggregate, coarse aggregate, and cement all together. The reason I'm using it is because it has finer aggregate. The coarse aggregate isn't as coarse as the others I have available in the lab. That's about as big as the pieces of coarse aggregate get. Since I'm trying to make my special concrete kind of light and fluffy, I don't want a lot of heavy rocks in there that might all sink to the bottom. We'll put 2 cups of the Quikrete into each of the buckets. Notice how fine that cement is in the mixture. The dust won't really settle down until we get it all mixed in with the water. These mixes are a little bit wetter than you'd really want concrete to be. Sometimes when you do an experiment, you find things you'd like to change and try the experiment again. And you can still see some of those bubbles in our special mixture. How wet concrete is and how easily it flows is measured with something called slump. As I fill up this test cylinder, you'll see how loose and runny the concrete with the soap in it is. Even the concrete without the soap has a pretty high slump. If concrete had to dry out instead of chemically reacting, this would never get hard. Now we'll make a test cylinder for our control. Because these have such high slump, we don't have to rod the concrete up and down to make it get the voids out of it. We just tap on it a little bit at the end. Now we need a quiet place for the concrete to set until it sets up and cures. Because we want both cylinders to be exactly the same dimensions, we'll strike off the tops and make it smooth. This also makes it easier. When we crush the concrete cylinder, we want a smooth surface when we press on both ends of it. So what will happen next? We'll have to take those concrete samples out of the cylinders, and then we'll have to see how much force it takes to crush them. We'll use a concrete crushing device that has a really strong jack in the bottom of it. When we turn it on, that jack in the bottom starts to push up. You can see that it's slowly raising up and making less and less space. When a concrete cylinder is in there, This digital display will show how much force is on the cylinder at any time. We removed the plastic coating from the outside the cylinder, and then we're ready to find out more about what we've got. So what do you think happened? Which of the two samples weighed less? Which one do you think was stronger? You have to become a construction technologist or a civil engineer to find out.